So, back on home-based learning, back to some videos and a new topic today. So, we are looking at what is a mole. Okay, so let's start simple. We're in chemistry, guys, not biology. So, a mole to us is something a little more conceptual than the moles you will have encountered before. So, things it is not. It is not a small mammal with a subterranean lifestyle in chemistry. That kind of mole, very much biology. Yes, they're small, black, furry, can't see a lot, big paws, but that's not what we're talking about in chemistry. It is also not a common type of skin growth, which you can possibly see. I have some on my hands. Yes, this is a type of mole, but not the one we're talking about. So in chemistry, we're talking about something that has a more abstract sort of existence. So in chemistry, we often shorten mole to MOL, take the E off the end, to avoid confusion with the two biology forms. Okay, so you will quite often see chemists write a mole as just MOL, even though it is actually spelt with an E on the end. So what is a mole? A mole is a unit of measurement for the amount of a substance. Now, I know quite often in chemistry we talk about not using the word amount, we use mass or volume, but in this case it is very much specifically a number. Okay, it is actually a number, and chemists say that 1 mole is equal to 6 times 10 to the 23 particles, and this is often called Avogadro's number or Avogadro's constant, after the scientist who first explained what a mole was. So what does that actually mean, this idea it's an amount of a substance? Well, when we have a chemical, any chemical in front of us, there is a lot of particles in there, okay? A lot of particles in there. And we already know from our work on atomic theory and looking at the periodic table and atomic masses that different atoms have a different mass. So we can't just take any chemical and weigh it to work out exactly how many particles or the amount of stuff that we have, because they weigh different amounts. And this gets even more complicated when you go from just simple atoms of one element to compounds and particularly mixtures. So we can't just weigh them to work out how many there is. So the idea of a mole is it gives us a number in invertedness of particles in a chemical, so we can compare different chemicals, different mixtures, different compounds without worrying about the difference of mass in the particles involved. So it's a way to get down to exactly how many particles there are in the hydrogen and the oxygen that we have before we react them to form water. So it gives us a comparison. However, the actual number's huge. Like we said, 1 mole is equal to 6 times 10 to the 23 particles. If I had 2 grams of hydrogen, it would have 6 times 10 to the 23 molecules of H2 in it, which is not easy to use for any kind of mathematical calculations. You don't want to be working in really ridiculously big numbers. So the idea of a mole is to simplify that mathematics. So it simplifies it kind of like when you would say, I am 14 years old, not I am 5,113.5 days old, because leap year's 0.25. So it's like that kind of idea, like when we say a week instead of 7 days, or a dozen eggs instead of 12 eggs. It's a grouping of particles that makes it a simpler number to work with. So the best way to think about this is talking about years instead of days. It's much easier to visualize 14 years than it is to visualize what 5,113.5 days looks like. So the idea of being able to visualize 1 mole is easier than 6 times 10 to the 23 molecules. So it is definitely a way to simplify it. So we say we have 1 mole of something, not that we have 6 times 10 to the 23 particles. Yes, I know I keep saying particles, and I know I go on all the time and say, be specific. Are you talking about an atom? Are you talking about an ion? Are you talking about a molecule? Are you talking about an electron? And then all of a sudden I've started using particles when we talk about moles. And the reason for this, guys, is because moles can be used to measure each type of particle separately. So you can talk about a mole of atoms or a mole of molecules or a mole of electrons, because we're talking about lumps of particle, lumps of stuff. So when we're talking about moles in general and say we can use them to work out particles, it's because we are saying you could use them for any of these things. So if you remember, I said 2 grams of H2 contains 6 times 10 to the 3 molecules, or 1 mole of molecules. I could equally say that 2 grams of H2 contains 12 times 10 to the 23 atoms, or 2 moles of atoms, because there are 2 atoms in each H2 molecule, so there are twice as many atoms, so there are twice as many moles. So you have to be very specific about which particle you are talking about when you state a number of moles. We could talk about moles for anything that you can quantify as a lump. So you could talk about a mole of human beings being 6 times 10 to the 23 human beings, a mole of rice being 6 times 10 to the 23 grains of rice. So you need to very specifically say, in this case, I'm talking about the atoms. In this case, I'm talking about the molecule. In this case, I'm talking about carbon dioxide molecules. In this case, I'm talking about the number of electrons around an atom. So you must be specific about which particle you are talking about when you talk about the number of moles.